Hello, welcome to ANS Solver. This is the seventh question of the paper. So, all the seats on a certain daily flight are always sold. The number of passengers who have bought seats but fail to arrive for this flight on a particular day is modeled by a distribution of 320, 0.005. So, explain what does 320 represent in this context? So, it's simple. 320 is is the number of seats, okay, is the number of seats on the flight, correct, or the max number of seats on the flight, okay, because obviously I know binomial is the distribution is basically n comma p, correct. So now the total number of passengers who have bought but failed to arrive for this flight on two randomly chosen days is denoted by x. Use a suitable approximating distribution to find 2 to 6. Okay. So now see here, okay, here what they have done is you need to use a suitable approximating distribution. So if you see here, you have this as n, this as p. Okay. What's the condition from converting from binomial, excuse me, from binomial, okay, to Poisson? Because see, I need to use Poisson here, okay, because if you see the condition is basically the n needs to be more than 50 and np should be less than 5. So if I calculate my np here, which is 320, 320 into 0.005, if I solve this on the calc, I get my answer as 1.6, which is less than 5. And I know even my lambda is equal to n into p. So I can say that my binomial is converted to Poisson with a lambda, okay, with a lambda of 1.6. But now if you see, they have taken 2 days here, okay, but the distribution here was for 1 day. So if in 1 day, okay, my lambda is 1.6, okay, basically in 2 days my lambda will be 2 into 1.6. So 2 into 1.6 is simple, 3.2. So this is my new lambda. So now I know the basic formula, which is e raised to minus lambda into lambda raised to x over x factorial. So now what do I need to calculate? I need to calculate between 2 and 6. That means there will be 3, 4 and 5. So probability of x equals to 3 plus the probability of x equal to 4 plus the probability of x equals to 5. Okay, so what I need to do is I simply need to write this as e raised to minus 3.2 into 3.2 raised to 3 over 3 factorial plus e raised to minus 3.2 into 3.2 raised to raised to 4 now, because your x is 4 here, over 4 factorial plus e raised to minus 3.2 into 3.2 raised to 5 over 5 factorial. So I can simply solve this on the calc if I want, yeah. So it'll take a little time, but we'll get an answer. Okay, even I'm writing it. So it's 3.2 raised to 3, okay, and then it's basically from, yeah, so yeah, so when I do this on the calc, the value I get is 0.515, which is the final answer of part 2. Now, justify the use of approximating distribution. So we've already covered this in the part 2. To convert from binomial to Poisson, I need my n to be more than 50 and my np to be less than 5. So I can simply use here my n is more than 50 because 320 is more than 50 and my np is less than 5 and my np which I calculated here is 1.6. So I can say 1.6 is less than 5. Yes, so this is the fourth part of the question. So now if you see, after some changes, the airline wishes to test whether the mean number of passengers per day who fail to arrive for this flight has decreased. So they choose randomly 5 days, okay, 5 random days and 2 passengers. That suggests that this is my test value, okay, this is my test value, okay, and they carry out the test at 2.5 significance level. Firstly, in the previous parts we saw my lambda for one day was 1.6, correct? That's what we even stated here. For one day is 1.6. So now you have taken 5 days here. So if one day takes 1.6, 5 days, okay, will be 5 into 1.6, which will give me a value of 8. So this is basically my new lambda. So now my null hypothesis, which is my first claim, states that my lambda is equal to 8 as it is, and my alternative hypothesis states that the lambda has decreased because that's what they have mentioned here. Okay, so now what I need to do is, I know this is p of x and I have basically my test value as 2. So the sign which will come here is basically, if this is less than, this becomes less than equal to. If this would have been more than, it would become more than equal to. That's the trick which we all know. So now because I need this will be equal to p of x equals to 0 plus p of x equals to 1 plus the probability of x equals to 2. So now I can simply write this as e raised to minus 8. I assume you know the formula, which is e raised to minus lambda into lambda raised to x over x factorial. Okay, so now I have this plus e raised to minus 8 into 8 raised to 1 over 1 factorial plus e raised to minus 8 into 8 raised to 2 over 2 factorial. Now to solve this, you can simply use a calculator method. So on the Calc, what you can do is, first click on shift. When you click on shift, click on the log button here. When you click on the log button, you get a summation sign something like this, with a box here, and a bracket here. So now what you do is, you are calculating the summation from 0 to 2. So in the lower limit, I'll get 0 and here I'll get 2. And here I'll write e raised to minus, I know my lambda is 8, into 8 raised to x over x factorial. X will take all the values from 0 to 2 inclusive. And to write an x, you can simply click on alpha and the closing bracket sign. Okay, so now what I simply, when I do this on the Calc, even I'll do it, give me 1 second. I'll just take, so this is a trick. So you need to write all your steps till here. It's, really important. If you don't write it, you won't get step marks. So even if your answer is correct, you won't get the right answer. Okay, like you won't get full marks basically. Okay, and now when I click on equal to, I get my answer as 0.0138. Okay, so now I basically need to compare this with my significance level, which is 2.5%, which is basically 2.5 over 100, which I can simply write as 0.025. So I have this as 0.025. So now I compare this. If you see, this is less than 0.0138 is less than 0.025. Okay, so now what I need to do is, because it's less than, I can say reject my null hypothesis. So I can say the average, okay, the number of passengers who failed to arrive have decreased, because that was my null hypothesis here. So it has decreased. I can say the average, or average number of passengers has decreased. Okay, this is what I can claim, because this is, my probability is less than the significance level. That's why I reject.